Okay, module 2 is about stoichiometric table and material balance. And the course outcome for this module is to apply principles related to chemical reactions to determine rate kinetics. And the course learning outcome for this module is, by the end of the module, students should be able to define stoichiometric table and explain the relationship between concentration of A and X, the conversion. Okay, so the outline for this module is to the first is the stoichiometric table, and second is relationship between concentration of A and X, and Ca and X conversion. Okay, stoichiometric table. Okay, what is stoichiometric table? Stoichiometric table represents the stoichiometric relationship between reacting molecules for a single reaction. So this is an example of a single reaction. So we have A plus B producing C plus D with the stoichiometric for each of it. Okay, so we have done this before. Relative rates and stoichiometric relationship. So this is the relative rates, and there's nothing new in here. So if A as a basis of calculation, everything is on a basis of per mole of A. Okay, so if A is your basis of calculation, you are assuming A is your limiting reactant. You are assuming that A is completely being used. Okay, therefore everything is divided by stoichiometry of A. Okay, so you will get this A over A plus B over A producing C over A plus D over A at here. So you will get this. When you assume everything is on basis of per mole of A, we are using A as your reference. Okay, so in the stoichiometric table for batch system, we are using number of moles. Okay, for Na, this is Na equals to Na naught minus Na naught X. So what does it mean? Na is the number of moles of A remaining in the reactor after the conversion of X. Okay, Na naught is the number of moles of A initially present in the reactor. And the Na naught X is the moles of A consumed in the system. So how do we we will try to understand this. So what's the difference? So in the real situation, initially is the number of moles of A initially present in the reactor is the Na naught. So after some time, when the reactions happen, and we stop the reaction maybe about half an hour, so we will identify what's left. Okay, so what's left? Number of moles of A remaining in the reactor after the conversion X. After we deduct with Na naught X, okay, moles of A consumed in the system. So that's why the reaction is like this. So what is the remaining of reactant in the reactor? So initially minus how much that has been consumed. That is the way we understand it. Okay, so this is the reaction, and this is when we factorize in terms of Na naught X, so we will get this 1 minus Xa at here. Okay, this is the schematic diagram for batch reactor. So we have a stirrer here, and this is initially at T equals to 0, we have Na naught, Nb naught, Nc naught, Nd naught, Ni naught. So Na naught and Nb naught is the reactant, Nc naught and Nd naught is the product. Even though we don't have product in the beginning, but we still put it as a symbol in your stoichiometric table to be used and as a reference. Okay, I referring to inert, any kind of substance which is not related into the which is not involved in the reaction. Okay, we call it as inert. Okay, so we put all the reactant inside. Okay, the initially, and then after some times, when we stop the batch reactor, when the reaction is finished at T equals to T, certain time that we set. Okay, so we have remaining the remaining of Na, remaining of Nb, Nc, Nd, and I. Okay, so we will identify what is the remaining. Okay, so this is a symbol, the important symbol that we will going to use in your stoichiometric table. Okay, so use stoichiometric table to express other species remaining after Na naught X moles of A reactant. Na naught X, how much of A that has been consumed. Okay, so please remember the equations. Okay,